these trigonometric functions is what we're going to look at. The first one is the sine function, and it's to do with the rotation. On here, we've got some sort of dot or something moving around in a circle, anti-clockwise. And we can make a note of how it's changing with respect to the y and the x-axis, and we can draw a little triangle in. So if I draw in the radius, and then this distance from here to here, and then this distance, which is the y-axis, the sine wave is to do with this. So as time goes by, and I were to draw this in, if it starts here and then is rotating round like this, at this start point here, then how far is this dot up the y-axis? It's not, it's at 0. So what we say is, for angle here, angle 0, the sine or the distance along the y-axis is 0. And as it comes around here, if I were to look along like this and see this point, how far has it gone up the y-axis? And when I get to here, it's gone that far up the y-axis. Come round to here, it's now gone that far up the y-axis until I get to the top, and it's the maximum distance up the y-axis. And we define the sine function with the radius of the rotation as being a nice easy number, 1. So what we say is, how far along the y-axis are we when the angle is 0? 0. So we say the sine of 0 is 0. How far up are we up the y-axis at 90 degrees? 1. To reach the top. Agreed, Matt?
Yep.
Or pi over 2, because 90 degrees is pi over 2. So what's the sine of pi over 2 if we're measuring it in radians? 1. Okay. Now it carries on coming around, and now it starts to fall again. Look at this angle. How far up the y-axis are we? Less than 1. It's started to drop back down again. What's this angle? It will be the angle from here to here. So it's this angle here. So the angle is now greater than 90 degrees, and this thing is rotating round. When we get to here, what's the sine of that angle? The sine of that angle, which is telling me how far up the y-axis I am. 0. And what angle is that? 180, or pi. Yeah, so what's the sine of pi? 0. We carry on going. So now, if I get to here, the angle now is greater than 180. It's round here. I get to this point and go across to here. What's the angle? What's the sine going to be now? What's the big difference? Negative. So I get round to 270 degrees, negative 1. And so on. Carry on going until I get back to here again, back to 0. So for one complete cycle, it's going from 0 to 1, back down to 0 again, to negative 1, and then back up to 0 again. And that's the sine wave. If I show that on autograph, I go y equals sine x, which you literally type in sine, S-I-N, sine x, hit OK, and I see the sine function. Now, if I look at this, drag the graph across, that's hand tool allowed to drag it. I'm only interested in, say, after this point here. At the moment, it's measuring in radians, which is there, that button. So you can play around with this. If you hit default scales, which is this, it will then tell you the angle in radians. So let's look at that and compare that to what we've just been talking about. Look. Now, I'm looking for the pointer tool. At 0, remember the sine of 0 was 0. At 90 degrees, which is pi over 2, so pi over 2 in radians, it's up to 1. And by the time I get to 180 degrees, or pi, it's down to 0 again, and then it goes negative. So in other words, what is this sine function? It's just telling us how far up the y-axis that we are as this thing rotates through one complete cycle. 2 pi, one complete cycle. That's what the sine wave tells you. How far up the y-axis have I gone in that one turn? If I put this in the notes here, you'll be able to see it. So let's go back to here again. So if I'm interested, and this is why the sine is the most common, if I'm interested in how far up the y-axis I've gone, then this is the one I'm interested in, because the sine tells me how far up the y-axis I've gone. This axis is often time, so x is often the time. This could be measuring voltage or current in a circuit. So what the sine is telling me is, as time goes by and this thing, voltage is changing, it's telling me what's happening to the voltage as I'm coming around, and the voltage is being created by something that's rotating. And some of you may know that alternating current is generated by a rotating coil in a magnetic field. So that's why AC gives us out this familiar sine wave. If I go back to autograph and hit degrees instead of radians, and then I hit default scales again, I'll then get one complete turn, but this time, look, it's in degrees. 0, 90 degrees, 180, 270, 360. So you don't need a calculator to tell you what the sine of 90 degrees is. It's 1. You don't need a calculator to tell you what the sine of 180 degrees is. It's 0. And what's the sine of 270? Minus 1. What's 270 degrees in radians? ,90 degrees is pi over 2. 180 degrees is pi. 3 pi over 2, isn't it? 3 halves. 90 degrees is 1 half. 180 is 2 halves, which is a whole one. 270 is 3 halves. 360 is 2 pi. So 2 pi, 3 pi over 2, pi, pi over 2. Okay? If you want to know what they are in between, then you use a calculator and it will tell you what the fraction, how far up this scale it's gone. So what is the sine of 45 degrees? Can you do that on your calculator? Sine of 45 degrees? Answer? 0.707. So in other words, this distance here, and if we go back to our notes, that distance there, so 45 degrees, which is pi over 4, so that distance there is 0.7071. That's how far up we've gone the y-axis, assuming that the maximum distance it goes up is 1, which is the sine. Okay?